As promised, we're going to walk through the failure modes effect analysis. The reading that I provided that comes from the book The Innovator's Toolkit by David Silverstein, Paul Samuel, and Neil DiCarlo, The Innovator's Toolkit, does a great job of doing this as well. And I should say that I highly recommend the book, The Innovator's Toolkit. It's chock full of all manner of different tools that you can use in the innovation process. But in any case, let's have at it. So first of all, you have the failure modes effect analysis. And it's this big, complicated spreadsheet, but we're going to take it essentially one step at a time. So the first thing that you do is you identify what item or task can go wrong or have an unfavorable outcome. So it could be anything. And if we go to our pizza dinner example, it could be the oven, it could be the preparation of the food, it could be the setting of the table, or even the dividing up of the pizza. Any one of those tasks could in fact possibly go wrong. And what we do is then we describe in what ways that item may potentially fail or have an unfavorable result. And in fact, there might in fact be more than one. So that oven could get too hot, could get too cold, for example. And then what we want to do is, what is the effect of the failure? How will that failure affect the project? And again, there might be more than one effect. Burnt pizza could cause, a bad dinner. It could also cause a late dinner because we'd have to recook the pizza. It could cause other kinds of effects as well. But what we want to do is understand the various possible effects of that particular failure. The next thing, what we want to do is we want to determine the severity of the failure. And here, this is be a handy tool to have with you when we go through the example. But it can range from the extreme to none at all. And notice that for none, it's not 0, it's 1. For extreme, you could have a catastrophic consequence. It could kill the project or delay indefinitely and make that project uneconomic, or it could affect the product safety. That's a 10. That's the most severe type of effect it could possibly have. Or it could be high, where the product is inoperable with a primary loss of function, with a high degree of customer dissatisfaction. It could severely delay the project and could certainly increase the costs. Moderate would be the product's impaired with some moderate customer dissatisfaction. Low, it's the product's functional but with some minor defects, noticeable by some. And then none, it basically have no effect whatsoever, or too minor to be noticeable by anyone. Then what we want to do is, after we've done the severity, how can the failure occur? Defined in terms of what can be corrected or controlled, and try to identify causes that directly affect that particular failure mode, that particular item. And again, there might be more than one. And then what we want to do is, what's the likelihood that it'll occur? And again, we rate this on a scale of 1 to 10, 10 being very high, that the failure is almost inevitable, 7 being probable, 5 being moderate or occasionally happens, low being remote, and then 1 where it's either none or the failure is fairly unlikely. And then what we want to do is we want to understand what the current design controls that are in place. What is in place to actually notice that failure? So what meters, what alarms, what gauges, what processes, whatever that'll actually detect that failure or prevent that failure from occurring. And then for each one of those particular current design controls, you want to actually evaluate what the likelihood that control will detect or prevent that failure. So here it's a little bit backwards. If there are no controls in place, that's a 10, which means that failure won't be detected if it does in fact occur. And that's quite often the case, particularly when you're dealing with development work. You may not necessarily know something's gone wrong until, in fact, it's too late. Low chance that the control will detect a failure, you give that a 7. Moderate, you give it a 5, and this is where it may detect the existence of a cause and subsequent failure or of unfavorable event. If the controls that are in place are highly likely to detect the failure, you give it a 3. And of course, if it's very high, which means it's almost certainly going to detect the existence of a failure, then you want to give it a 1. And then what you do is you calculate the RPN, the risk priority number for each failure mode. You simply multiply severity times occurrence times detection, and then you rank order the various failure modes because you want to do the ones with the highest number first. Make sense? Okay, so that's the process. We'll pick this up with an actual discussion about risk mitigation, but before we do that, we'll also take time to walk you through the example of the FMEA using an actual spreadsheet.